In previous tutorials, we've mixed synchronous and asynchronous methods for simplicity, but in this tutorial, we'll be going fully asynchronous. Now, go in the description and download the starter GUI. Once you've finished doing that, let's continue on with the code. Now, go over to Server and add a new item. And name it client.cs. First, we're going to create a new structure. Struct receive buffer public const int buffer size equals 1024. This will be our set buffer size that we'll use to receive data. You can change this to any value you like. Public byte buffer public int to receive public memory stream buff stream. Forgot our includes using system.net and using system.net.sockets. All the data we receive will write to this stream. Let's make our constructor public receive buffer int to receive buffer equals new byte array of the buffer size to receive equals to receive and buff stream equals new memory stream of to receive. So we're creating our new byte array of buffer ready to receive information. We're setting the length of the data that we're expecting to receive to our variable in our structure, and we're creating a new memory stream which will store the actual full packet of data. Now let's create a new void, public void dispose buffer equals null, to receive equals 0, close, we'll write that method in a moment, if buff stream not equal to null, buff stream dot dispose public void close, if buff stream not equal to null and buff stream dot can write, which means it's still opened, buff stream dot close. And as basically what it does, it's what the name describe as well. It sets the buffer to null, sets receive to 0, closes the stream, and if it's not equal to null, then it'll dispose it. This is to prevent any errors from occurring later on in the code, which you will see. Now that we have that written, let's code our client class. Byte len buffer receive buffer and socket public IP endpoint get if socket not equal to null and socket dot connected, then return cast to IP endpoint socket dot remote endpoint. If the socket is equal to null and it's not connected, then it will return a new IP endpoint, IP address dot none and port 0. So this is just a method that will help us get the IP endpoint in our class. Now let's create some delegates and events. Public delegate void disconnected event handler, client, sender, public, event, disconnected event handler, disconnected, public, delegate void, data, received, event handler, client, sender, receive buffer, E. Public, event, data received, event handler, data received. So the delegate voids are just basically handlers for the event. There's another way you can do this, but that's too much code that's needed. Not necessarily too much code, it's just this is a lot easier to do as of now. I will show the other method you could use in the description. Now let's code our constructor. Public client socket s. Socket equals s, and len buffer equals new byte of 4. So of course you recognize this. It'll transfer our socket that we'll accept with our listener over to our socket variable in our class. And len buffer of 4, this will hold the bytes of the length of the data that we are receiving. The length of an integer in bytes is 4, so that's why we make the byte array 4 of 4. Now let's continue. Public void close. If socket not equal to null, socket.disconnect false, socket.close. You could just call socket.close, or you could call disconnect first then close. Close basically does the same thing as disconnect, but I prefer calling. You can prefer calling disconnect first and then calling close, but it all just depends on you. Buffer.dispose, socket equals null, and the rest is just setting everything to null, waiting for the garbage collector to do whatever with it. Disconnected equals null, and data received equals null. Now public void receive async. Socket dot begin receive len buffer 0 len buffer dot length socket flags dot none null null void receive callback async result AR try catch int res equals socket dot end receive AR. If res equals 0, meaning that there's been a graceful disconnection, if disconnected not equal to null, disconnected this. Return. If res not equal to 4, throw new exception. That just means something screwed up. Now let's catch a couple more things. Catch socket exception, SE. Switch, SE dot socket error code. Case socket error dot connection aborted, and case socket error dot connection reset. Break. If it's either of these two, that means there was a disconnection. If disconnected not equal to null, disconnected this. Return. Catch object dispose exception. Return. catch, no reference exception, return. Catch, exception, EX, write the error to the console, and return. Now, after we receive the length, buffer equals new received buffer, bit converter, to int32, the length buffer, start index 0. Socket dot begin receive buffer dot buffer 0 buffer dot buffer dot length socket flags dot none 0 null and null. Void receive packet callback async result AR int res equals socket dot end receive AR if res less than equals 0 then return. Buffer dot buff stream dot write buffer dot buffer 0 and res buffer dot to receive minus equals res if buffer dot to receive is greater than 0, meaning we still have more data we have to receive. Array dot clear buffer dot buffer 0 buffer dot length. We got buffer dot buffer dot length. Socket dot begin receive buffer dot buffer 0 buffer dot buffer dot length socket flags dot none null receive packet callback null and return. If all the data has been received, the data received not equal to null, data received, this buffer, dispose the buffer, now that we're done with it, and begin receiving again. Now let's review what we have thus far. First, we're getting the amount of data that we have received from the current buffer. We check if it's less than 0, then just return. This can mean a couple of things. We write the buffer to our stream. We subtract what we have received from our total length. If the length is greater than 0, then it means there's more to receive. We clear out our buffer and begin receiving again. If it's 0, then it'll skip this altogether and go down to here. It'll call the event that data is ready. We'll dispose the buffer and begin receiving again. And there's something I forgot here. Buffer.buffStream.position equals 0. This is so it'll be ready for reading, and you'll see that later on in this tutorial. Now let's go back up to receive async and add our receive callback, and go down to the receive callback and add our receive packet callback. And now our client for our server is ready to go. Now first let's go up to above receive buffer, and we will add a new enum which will hold the commands for our server and our client. Enum commands of int text or string equals 0 and image. You can use image or image equals 1, but it'll auto accumulate. Okay, now let's add a new item. Listener.cs using system.net using system.net.sockets public delegate void socket accepted handler socket e public event socket accepted handler accepted public socket listener public int port public bool running get private set public listener port equals 0. Public void start int port if running return listener equals new socket address family internet network socket type stream protocol type TCP listener find new IP endpoint. You can either use IP address .any, meaning it will accept any IP address, or 0, which means the same thing. Port listener .listen 0 listener .begin accept null void accept callback async result AR try catch socket s equals listener end accept AR if accepted not equal to null accepted s if running try catch listener begin accept callback no. Then go back up to start and change null to the callback. Public void stop if not running return listener close running equals false. And now we have our listener coded. Well, now that we have our socket wrappers ready, let's integrate this into a form. using system.io, using system.net, using system.net.sockets. Listener, listener, client, client. btn listen plus equals, we got click, plus equals, let's press tab twice, btn close dot click plus equals, tab twice, and form closing plus equals, form closing with a handler. Alright, now in form closing, if client not equal to null, client.close, if listener not equal to null, and listener.running, listener.stop. In btn close, if client not equal to null, client.close, client equals no, listener.stop, lbl info.text equals connected, no, list text.items.clear, pb image equals no. Now in btn listen, listener equals new listener, in listener dot accepted plus equals in listener dot start 8192. Now in listener accepted, if client not equal to null, close the current socket. That means where we have a client that's connected. We're only dealing with one connection as of now. And return. Client equals new client. Pass a socket. Client.data received plus equals tab. Client.disconnected plus equals tab. And client.receive async. Invoke, method invoker, delegate, lbl info.text equals connected, plus client.endpoint.toString. Now, basically, in a nutshell, what invoke does is whatever, in the way we're using it, whatever is in between these brackets will be executed on the control's main thread, as you can read here. Now let's head down to disconnected. Client.close, client equals null. Invoke, method invoker, delegate, lbl info.text equals connected, no. Dialog result res equals message box.show, client disconnected, clear data. Mix parts button with yes, no. If res equals dialog result yes. List text.items.clear, pb image equals no. Now let's head over to data received. Binary reader R equals new binary reader E dot buffer stream. Int, we can do commands header equals cast to commands r dot read int 32. Switch header case commands dot string break case commands dot image break. String s equals r dot read line, read string, invoke method invoker delegate, list text dot items dot add s. Int image byte len equals r dot read int 32. Byte I bytes equals r dot read bytes image bytes len pb image dot image equals image dot from stream new memory stream of the bytes. If pb image dot image not equal to null, pb image dot dispose, and got invoke method invoker delegate, invoke method invoker delegate, now you'll see how this comes into play later on when we code the client, but as of now it creates a new binary reader, it gets the header that we have written to the stream. When we code the client you'll see that come in effect, and we'll check the command. If it's a string, then we'll read the string and add it to the list. If it's an image, we'll get the bytes and then we'll create an image from stream. I bytes equals null. And now we have our server ready to go, and next video we will code the client.